Good afternoon, everyone. My name is Jason Lopes. I currently work at Carbon. I'm a production development engineer. I have about 15 and a half years in photopolymer additive before joining Carbon. I worked heavily in the entertainment industry, pushing the boundaries of materials and technologies to do direct manufacturing over 10 years ago. Something that is very relevant today with the messaging that we hear from all of the OEMs about we've gone from prototype into now a production mindset. Well, this is great, and we have a lot of people adopting it. The goal of this discussion today is to really have the audience feel comfortable and know they're not alone, to know that since we are now thinking production, there's still a lot of unanswered questions to get us there fully into production. And today we have a lot of interesting panelists that I think are going to be able to mend us everywhere and share the same story. And we also want the audience, if possible and if comfortable, to ask questions as well towards the end that help engage this discussion a little bit so we can exploit where we need to focus to make it easier for everyone and grow this reality. So I think our panelists are pretty much ready to join us on stage. So without further ado, here's our selected panelists for today. And we'll let each one of them introduce themselves. And I think once you hear everyone's backgrounds, you'll see how the synergy of this discussion can really bring out and show that you're not alone out there. And we can all come together to do this. So we'll start down here. Hello, if you want to tell everyone who you are.
Is the mic working? Can you see me? Perfect. Yep. Great. So, hello, my name is Florian, and I'm the CEO and co-founder of Trinckle. And at Trinckle, we're automating design process. What does it mean? So our pitch is you need to stop me here. It's smart. Okay. You basically need two things. You need for printing. You need a printer and you need a design, very basically. So in printing, you guys have done a very good job. So printing is getting better and better and almost a commodity. But on the other side, the designing, not much has changed actually. Designing is still done manually. And this wasn't a problem in the old times when you could actually design and distribute the design costs over millions of pieces. But now, for additive manufacturing, you only have small batches and actually single pieces, and then design costs actually matter. And so we went into this, had a look, what can we automate there within this process to make design costs come down dramatically. And so we're able nowadays to reduce all kind of repetitive work, to automate configuration, customization processes, and for all kind of product where this is necessary and makes sense.
Thank you, Florian. And our next panelist, introduce yourself.
Monahan, Associate Director of Computer Engineering at BD. BD is a global medical company, a solutions company. I have been there 26 years, 25 of those have been in additive manufacturing. I lead a team that supports our entire corporation worldwide with prototypes and now into even some additive production, which having been in this business for 25 years and working for a company that molds over 700 billion parts a year, it's pretty exciting to see where the technology has come and that we're actually into production using additive manufacturing.
Thank you, Larry.
Hi, everybody. My name is Jay. I'm the CEO and founder of a company called Dinsmore. We're located in Southern California, beautiful sunny Southern California. Happy to be here with a little bit of weather change. Sunny and 70 gets boring, so thank you all for coming and sitting here and listening to us. I was lucky enough to get into this industry 27 years ago, so I've been doing it more than half of my life, which is kind of interesting. It's the only thing that I know and that I'm very, very passionate about. So we service all major industries: automotive, medical, aerospace, consumer products. The business started with consulting and doing a lot of R&D and engineering work and prototyping. And about the last 5 years, we've really shifted that to being into full-blown additive manufacturing using most of the major technologies that we have at Dinsmore. So SLA, SLS, FDM, PolyJet, MJF, DLS, DLP, and we're in production with every single one of those technologies, which is kind of crazy. So thank you all.
Thank you, Jay. Roxanne?
Hi, everyone. My name is Roxanne Warren, and I'm with Link3D. We are your workflow additive manufacturing execution system, specifically, again, for additive. My background is a pretty diverse one. I come from software development, program and project management, most specifically in manufacturing. I've most recently been at both Arconic, and my team was qualifying the Airbus Pyramid Bracket in powder bed fusion. And then prior to Link3D, I was working for North Titanium with their high deposition additive manufacturing, and again, aerospace qualification programs for Spirit and Boeing. So thank you guys for coming, and look forward to being a part of the panel.
Thank you, Roxanne. Kenneth?
All right, I'm Ken Vessey from Underwriters Laboratories, UL, senior staff engineer. I've had 30 years experience with traditional manufacturing, and I'm fairly new to the additive manufacturing, about 5 years, and I'm still learning, which I think is great. But I'm trying to bring a perspective on safety regulations and safety certification sides to assure safety in electrical and electronics as well as automotive products.
Thank you, Kenneth. So as you can see, we have a big variety of players in this space, and I think that's what makes this special. In my whole career, the reason why I was able to pull off the work that I did that people were blown away with was because of collaboration. It's because everyone that makes up those teams that has a different job, has a different set of responsibilities, and more importantly, has a different knowledge base for processes. All of that comes together to help us get from A to Z. And when I say A to Z these days, I consider A to Z prototyping is A, production is Z. But we're realizing all the other letters in between are kind of not defined for us, and there's a lot of unanswered questions going into production. So the first high-level, very easy question to throw out there to get this started, and I'm just going to literally throw it to Larry first, since he's sitting right next to a service provider, and I think this will generate some interactions and very unique views, and especially if you look at the end of our panels, over here and over here, we have safety and standards, and we also have new ways of designing and bringing that into the mix, so we should have some cool synergy. So the first topic we're just going to kick it off with is, what is the right technology for your application? And what I mean by that, I know that sounds generic, but there's a lot of drivers when an application comes across your way and you have to make a decision to move forward. And that decision, is a different decision for everyone sitting up here on this panel. So Larry, application comes across your desk. What's your first take on choosing the technology to start driving that into production?
Who designed this mess? So, fortunately for us, is that my team they're going to generate over 100,000 prototypes internally this year. So we work closely with the design teams throughout their process. And as we're doing that, I've had a lead engineer on each of those technologies. And what works really well for us is that we do something totally, I think it's crazy, but we do it anyway, is my engineers talk to each other. So they start working on these projects early on and looking at which technology works best for material properties, performance of the parts, the geometry, the accuracy, all of these things. And so if my carbon engineer looks at this and says, this would be a better part in another technology, we'll talk to that engineer, and they'll go back to the designer and work with that group, and working out till now we're ready to go to production. We've already moved into that direction in our prototype phase. So early on, we start those conversations.
So that's very interesting. So you're hearing it right now from what I'm going to call like an OEM customer that is not out there trying to sell services. They have a need for applications, and Larry's approach that comes across his desk, we just heard it. So my question to build off of this that might be able to lead into more people on the panel now is, what if it's a technology that you do not have? How do you educate yourself on that technology, choose that technology, bring it in, and then start validating for the production process within your organization that might be set up already with all of your investments on other additive equipment that's been there? Do you reach out to a service bureau like Jay Dinsmore and get his take and experience in it? Do you reach out to other industry veterans to get their take in it? want to
say what I'll do, and they made this quote to Jay. There are so many technologies out there. There's so many platforms. I think it is virtually impossible for everybody to know everything about everything, and I think it'd be a fool to think that you can. So the answer is yes. Is I'm going to go to so I think that I know, and reach out to those equipment manufacturers, those OEMs. And then who's using that technology? I'm going to go to the Dinsmores and those like that who are running those machines every single day. And that's where we go from internal engineering between myself, my lead engineers, our designers, to now we bring in either the OEMs or the service providers who run that technology every day. And so we would reach out to them like a Jay, this is what we want to run. You've got the experience doing it, and work with them to continue down that path.
Right. And we'll tell you what the OEMs won't.
Oh, absolutely. Yeah.
Yeah.
I think that's very interesting, a topic you just brought up. So,
not to pick on,
Yeah, but by Larry reaching out to an existing service provider that's, on the leading edge of all the technologies as a whole under the roof, Jay brought up a very good point. He fills in the blanks where the OEMs leave off and really get Larry and other companies to understand the things that you don't find out in marketing per se, which now we have a situation where there's a new technology. Larry has determined that this will work for the application that's come across. Jay has consulted with him. They've made a choice. Now we have a couple different things going on here. Does Larry's team need to learn a new way of designing for this specific technology, right? Safety standards of bringing it in-house, where UL's specialty is. Are there new considerations for bringing that actually into at least R&D this before bringing it into production? And we have a lot of crossover here. Right here, we have a guy here that's coming up with a new way of bringing designing to engineers for new technologies, but what we come across with is these people that are now looking at these new tools have been doing it for 20, 25 years, and I experienced this at my previous job trying to bring in technology. The engineers have their guards up. They don't want this new way of working. They think that it's going to automate and possibly replace everything that they've learned. So you have that friction. You want to maybe compile on top of that. Is that something that you have to overcome as well?
Of course, we would have to. And when I pitch our benefits to a designer, then most of the time, I sometimes provoke a little bit and say, we want to replace you as a designer with algorithms. And then it's like, whoa, why and how? And it's actually, it's not so much replacing the engineer or the designer, but it's giving him a tool to do repetitive work, actually, and to free a lot of boring work, or to help him to get rid of a lot of boring work, to have more free time to actually do the really funny and great things where he can put all his creativity into it and create new cool things. And also, in this new age of additive manufacturing, where we have these single items we want to print, why should we print 1,000 same pieces if we can print 1,000 different pieces, actually? The machine doesn't care so much, and especially in MedTech, where you actually want to maybe make the customer or give the customer the benefits of that they have perfect fitting devices and orthotics, for example, reflecting the shape of your unique knee or something, then give the advantage to the customer with this. But of course, then designing it needs to be somehow able to reflect this, and it needs automatically to customize these kind of things then. And therefore, this is something an engineer wants to make maybe 3 times, 4 times, but not more often. And then it's cool if he has algorithms that does the job for him.
Gotcha. Cool. So there's a lot of levels to this. I mean, making a prototype onesie twosie is one thing. Even taking that prototype now and saying, well, it 3D printed, let's make 50,000 of these and get it out into the real world. It becomes very, very complicated. I want to actually throw the next topic out to Roxanne, because Roxanne's aerospace background, and this is a question that I get a lot every day, and I'd be really curious to see how a service provider like Jay Dinsmore can hop in on this as well, and I'm just going to throw it out there. how do we ensure machines across distributed manufacturing settings can achieve repeatability?
That's always a fun one, especially when you're talking about any kind of regulated industry, aerospace, medical, etc. And it's actually one of the things, given that I was a former plant and operations manager, was I considered it an elephant in the room, if you will, because today, when you're qualifying a part and you've got a customer that you're working with, it's established a very fixed process that cannot change, and you have to ensure repeatability, as you're noting, Jason. You've got to be able to do that not only today, but tomorrow. So if you think about the maturation process of, let's say, desktop computing or laptop computing, everything changes. Back then it was every 6 months your computer was out of date. Today, as evidenced by Formnext and the rapid growth of it, the printers are continuing to change. The technology is continuing to change. And so in order really to be able to guarantee that repeatability part over part, day over day, year over year, it really comes down to the data. You've got to have access to the data. You've got to be able to leverage that data in a way that assures your OEMs, your certification bodies, that you actually can, in fact, repeat the parts over the course of time. And it really is an elephant in the room for pretty much the industry right now, because your printers are changing. The software revisions of the printers are changing. If you're a laser bed power manufacturer or laser bed printer manufacturer, your lasers are changing. There's all kinds of technology that's changing in your printer.
Actual safety at the site to avoid hazards to humans, to people, to environmental concerns as well. So all those three safety aspects come into play as we're looking at these different chemicals that are used, the different metals, the powders, and everything that can come off from the processing of those. So it goes through a whole different level on that safety, facility safety as well. On the plastic materials as well, we run into even more hazards and concerns. When you talk about material certification, we've done material certification, and again, a lack of, I'll say, robust materials out there that have been evaluated, tried, and true, and then to continuously assure that those materials maintain the same through identification, processing, testing is another area which I think the industry is really starting to grow now.
And I believe that I've got a pretty extensive experience in molding and machining as well. Traditional manufacturing, I like to call it, but as most people do. And these are similar challenges that we face with traditional manufacturing. I don't know if any of you have ever experienced, let's say you're molding something abroad in China or wherever, you get in, 5,000 parts, awesome. 5,000 more parts, awesome. They pass QC, come in, they meet spec dimensionally, but your customer calls you, a few months later and says, hey, these things are like falling apart, So, it's not just specific, I think, to the additive manufacturing and 3D printing world. I think it's in traditional manufacturing as well.
Thank you, guys. And Andrew has a question before we move on to the next topic.
It's only a quick one related to this. One of the things I've always found is there needs to be more communication between the material suppliers and you as a service provider, because I've seen several cases where you think you're getting the same material and they've actually changed the components and they don't tell you.
Yeah,
yes,
sure.
That's a huge issue when it comes to this.
It absolutely is. And that communication is key in making sure that contractually they're locked down and they know that they cannot make a change without notifying you. Still doesn't necessarily prevent it, but that's where the receiving inspection becomes very important, and being able to store that into a database where you can actually start looking at the data. I think we can all agree we've got a lot of data, but I think we can all agree that we also don't look at all that data, right? And so how to take that data and really enable it so that you're doing something value add with it becomes very important.
I'm so glad that you brought up data, and that's definitely going to be a topic on here, and it's one that I really have a lot of feelings about. But you had said something earlier when you were talking, and this is one thing that fascinates me. We are now evolving from traditional manufacturing methods and moving into digital manufacturing using all of this amazing equipment. The people that have been involved in traditional manufacturing have not had to deal with one piece of the puzzle that we have today. and that's software. And I'm going to throw out, after we talk on here, to someone else that's in the audience that also has another service bureau, Chip here from TTH, because I want to hear his take on this as well, is when we have this new layer of software involved, and we lock and validate a part and a file and going into production, does it hold back the traditionalist in an organization knowing that there's this unknown? What happens in 3 years from now when we go from a version 1.2 piece of software that's driving the builds of this production to revisiting it now when we're on version 5.6, and what's changed? Does that hold people back from the fear of unknown until there's more documentation coming out of the OEM saying how this is going to be handled in the future, or is it just the land of the unknown at this part?
I'd like to say that it would hold people back and create a level of caution. I'm not convinced from an industry perspective we're quite there yet. Again, sort of an elephant in the room scenario. I don't know that we think that far ahead and really plan for that. I mean, you guys can correct me if I'm wrong from your experiences, but I think we're starting to get that mature. We're starting that growth pattern and level of maturity. I think we do have a ways to go to really ensure your regression testing from a software, if you look at it from a software perspective, it's all about regression testing at that point as you're continuing to mature your machines, your processes, the material, and making sure that it continues to comply.
So, like Chip, I mentioned you earlier. Chip's in the audience. He has a service bureau, the technology house, and he's actually done some volume production utilizing additive methods. Has this come into play at all for you, possibly in the middle of a production, going back and revisiting a production down the line? You want to maybe throw into that?
Thank you for calling on me.
You're welcome.
Catching the unexpected. We're working with a medical device manufacturer who is looking at a production opportunity and using one of the machines that we know well. And what we actually had to do was freeze two machines on the software. So we locked them down. I mean, which means we've got to go back to the machine manufacturer. Also, then they wanted to guarantee that we could do 5 years of production. So they forecast ahead what 5 years of production would mean to them. And if the source of the material provider was to change the material or anything, they had to have enough for us to buy 5 years of their production material available. So all of this, we talk about legal agreements. I never expected to hire a lawyer to my staff, but my legal bills were getting so expensive on contracts. We actually have a lawyer on staff now, just because of all the contracts, NDAs, type stuff going back and forth. But the volumes you're looking at in the early stage, this is very important, and we understand it because we do a lot of machine parts and injection mold parts where we have the FDA-approved processes. So we understand this, and you just have to decide, with your customer, is this valuable enough for them and makes sense to us to do it. So and just what you said, I see a lot of interesting things here, but as I was talking to my wife, you just can't swap from one material provider to another when you're going into production. You really have to look at SERPs and every issue you talked about up there we've experienced, even where the SERP comes in with a material and we find out later they gave us the wrong piece of paper or something. So,
exactly.
Yeah.
Jay, do you want to chime in on that, and Larry as well?
Yeah, sure. It's that, Roxanne, this is not just an elephant, it's a very big elephant.
Oh, it's a very big one.
And, even as early on as we are in this right now, this is a big concern for our operations people, our procurement people, and I have a whole team of those folks who are working with me now on this. And on the technology side and on the OEM side is that I want my machine to run better and faster and more accurate and do all these things. And the OEMs want to give you machines that are going to run faster and do this and do software updates. And our operations people are like, whoa,
exactly.
Is that we're going to just keep ride this old horse here and go steady with it because we don't know how to handle these software updates.
Right. And
we're going to have to pull machines off and dedicate them to running the same process over and over again until we find a way to do this. This isn't a molding machine that we're going to run for 20 years under the same conditions.
We were talking about that last night, Larry and I were chatting a bit, and It's an interesting one because I was sitting on another panel a few weeks ago. One of the first things that I did with seasoned veterans in the industry, that I was telling them that it's our duty for our industry. Everybody's talking about 3D printing is going to take over the world. I have friends of mine that own injection molding companies and machining companies that are calling me going, "Jay, should I sell my company because you guys are going to put me out of business in like 2 years, right?" And I'm like, absolutely not. But if I drew a big circle right here and I drew a little tiny line with the number 2 mechanical pencil, that's what our industry represents right now for the trillions of dollars of manufacturing that's out there. And we're trying to get a bigger slice of that pie, right? And we need to educate first, I think, and this is a really good thing to bring up. I've been right, like Chip, you probably the same thing. I'm not going to say which technology, because I don't want to pick on anybody, but I've been right in the middle of a medical production job and had updates come in, and all of a sudden we're in production, and now I'm not in production because something happened. And it's the same build, same technology, nothing's changing, same operator, same material, and all of a sudden we're like, whoa, these parts are way out of spec. What the heck happened? And that's a big problem, especially when we're telling the world that, yeah, we can do this like injection molding or machining. Well, guess what? As soon as you say that word, what do people expect? They know molding, they've been doing it for years, and it gets even worse when you start talking about, like, well, Larry, a program manager at BD that's been molding parts for 20 years, do you think that that individual wants to put their stamp on additive manufacturing if Larry can't answer all those questions about software updates and machines? And so, yeah, it's a huge issue.
Yeah, and first of all, I want to thank you for throwing a Nerf dart at me rather than a regular dart. I know you were going with certain things, so I really appreciate
I didn't
that.
say carbon. I didn't say PLA.
I get it.
I can name several of the manufacturers.
I'll take a Nerf dart any day.
I may have looked over at you when I was thinking.
But I think this is something very interesting that's happening here. We have 5 people sitting here that are charting the unknown and are actively charting the unknown. And I hope this opens up comfort to really ask these questions, because people have answers and have experience in this, and a lot of times an OEM is not going to provide the true answer that you need. And you'll be able to talk to the J. Dinsmores and the Chip Gears and really get that guidance of how they charted these territories. I mean, we're looking at pioneers here going through this, and in all of my speeches that I've done over the years, I always go back to the pioneers in the industry, because we wouldn't be where we are today without those pioneers. So how do we get you tomorrow for us to be in awe? And that's you being comfortable speaking to active users that are actually experiencing these workflows and understanding.
So Jason, just to build real quickly on that, I think one of the things the industry is lacking as a whole is really looking back. Right? How do we take what UL has done for years to qualify parts, right? And to be able to provide the UL stamp? What can we take from a forging house, a forging vendor, a casting vendor? They've been doing this for years. They're going through the same they went through the same growing pains 50, 60 years ago that our industry is going through right now. So how do we take those lessons learned and apply them today to our technology, our processes, so that we can minimize those pains? They're out there. Those lessons learned are documented. I'll tell you though that workforce, I'm older than I probably look, but those relics, if you will, are leaving the industry, and we've got to get that knowledge harnessed before they do, because those are the lessons learned that we really need to start applying before that knowledge really is gone, that intellectual capital is really gone. We've got to get that in place.
I like what Roxanne just said, and I think this applies in a lot of areas. I have a really interesting story when I was working in special effects. I brought in all this new technology. We adopted it. It was doing phenomenal things for us. And then I was tasked with making a 5-part mold assembly for this Geico Gecko laser for a commercial. And just because I had software, I had computers, and I had 3D printers, all of a sudden, this monumental task was dumped in my lap to make this 5-part mold. So I sat there for a little bit, and the next thing I know is, I know how I'm going to do this. Well, fast forward to 3 hours later, the person that tasked me walks through my design room, looks down and sees this guy with material all over him, ripped shorts, and he's just like, what is he doing in here? And I go, well, I brought Javier in here to do this for me. And he goes, what do you mean? Javier doesn't know how to use a computer. I go, Javier's been molding for 25 years. You tasked me with this job. Why am I going to do this job? He's the expert that can now use this tool in a different way to solve problems that he or she may have had years ago and actually give us a better product. I'm going to revisit the people that did it manually before there was that button to just do it automatically. So I think that's a very good point. And for every 2 steps forward, I've spent 5 steps backwards to go forward and get there. And I think that's really neat to be able to apply that. So the next topic that we're going to get into, and it's funny, this is kind of like an oxymoron topic, and I'm going to call out Jay Dinsmore on this.
Oh, great.
Jay Dinsmore and I speak a lot about the industry. And one of Jay Dinsmore's frustration with the evolution of workflow into this equipment is, why can't a machine tell me how to build this part? I want to be able to take a file, bring it into a machine, and have that machine tell me how it's built. Because we should be able to do this by now. This is once again off of Roxanne's little blurb that she said. So my question here is parsing data. Getting data, right, that everyone wants data and everyone wants things better. It's a back and forth with giving data to someone who needs to create and program a solution. So my question is, for us to take this data to make better solutions in the future, it requires one thing. You need to give that data, which most places will not do. They do not hand over data to an OEM. So the question here is very simple. If Larry can email Jay Dinsmore a file for a quote, why can't Jay Dinsmore email data to an OEM to make a better product?
And this other panel I sat on, it was actually Stratasys, and there were some higher level people in the room asking us, as we're all preferred parts provider programmers, about 20 of us in the world, and we're all sitting there and they're asking us about software, and, well, what do you guys want? And everybody starts arguing about, like, oh, build styles and this and that, and I said, it's real simple. We want to be able to take data and swipe, if I could just put my arm out like this and take a bunch of data and just go right into your equipment, and your equipment is telling me what material, how to build this thing. Don't do it this way, it's going to fail. It's real simple. In my mind, that's what I see. I see data just in, and I asked the question, I said, you're asking all of us to tell you what you should do with your software. I'm like, you guys, it's real simple. You guys should be the ones, like, where your machines are making the parts, and why do they not have more machine learning built into the software where, one of our friends built a very large Longterm part that failed the first time, and it failed because of airflow in the chamber. And I'm like, that's just insane. Like, as soon as you load that sucker up and you know the machine knows it's going to fail, it should tell you, right? So that's what I see. It's data just slid right in, it does its thing and tells you and orients and does all of that for you.
I get that, but an OEM that's building a hardware solution, a software solution, and bringing in material to validate with their process, they don't have this library of data and these real-world examples that all of us see every day coming across their desk. Yeah. There's not this data just available to them. And, I've been involved in alpha programs, beta programs, where I provided all I can to an OEM to help advance a product. More times than not, you can't provide. Right. So how does an OEM cross that barrier with limited data coming in from the real-world users?
Right. Well, I think the part of the problem is, it's pretty simple. It's data and intellectual property, right? And I think that's where a big part of it comes into play, right?
Yeah, there's certainly a lot of IP and legal are going to they're going to slow that whole thing down. Yeah. I go through this all the time, not just with getting parts out to service bureaus or providers or OEMs, or connecting an internet connection through my network to someplace else. It's battle. It's a battle, but you know, I'm going to say it's a battle, but there's a reason why it's a battle too.
Yeah. I think if you're like sharing more with the OEM, right?
Correct. With us.
And same thing. It's like
them to share with us.
It's got to be a.
Yeah, I totally get that, and you know, a lot of people in the room and in your organization, we have access to designers and engineers. Why can't we be starting to build up a synergy where we can tell these engineers when we've gone through failures and big failure rates, say, hey, I need you to recreate these problems so we can get that data over to an OEM so they can see or understand this example that we're trying painfully to describe on the phone or in an email and text.
Right.
So, you know, it's a very interesting topic. It's a very difficult topic to talk about, and I'm sure this plays into your world a lot. You know, the minute I'm assuming your platform, your way of working is taking advantage of cloud computing in some matter. I know you do computational generative design with it. That's a whole nother ball of wax right there. Dealing with the cloud inside of all of this. You want to maybe speak to that a little bit and how you overcome some obstacles in that?
Yeah, of course. First of all, I found it pretty interesting. So I'm much more, for my business, I'm much more looking into like applications and what could people do and print, and then we are thinking about the designing, and then our job ends, and then we do it further, and then it's like, it's really interesting of what many problems and things you still have to solve every day. I really noticed this again now. It reminds me to the thing you said at the very beginning. We started at prototyping, we jumped so far ahead actually, and there's still so many steps to do, and it's quite interesting. But coming back to this question of data, yeah, of course. I mean, there's so much things you could do if customers would actually allow you to use data more generally, even anonymous, for doing kind of AI, machine learning stuff and so on. But it's super difficult. You know, we have a cloud system, and it's even difficult to convince people to use this cloud system for themselves. They want to have it on their own computer, on premises, actually. This is what they prefer. Nowadays, they're like, maybe we can have our own cloud, kind of. And it's like, okay, then let's have a common cloud. And then the next step would be, and now let's kind of share the learning of your data with other ones. Not sharing your data, but the learnings you had with this data. And I guess like it's still a long way to go, but we could profit a lot if we would share more of these learnings from how to work with data and so on.
Cool. So if anyone doesn't have any questions kind of on this data topic, Kenny's been very quiet, and it's very difficult to fuse questions into Kenny. And I kind of, as everyone's talking here, I kind of, my mind goes everywhere. I'm an artist by heart, so I'm thinking about 50 million things at once. And one trend that I see, I'm going to throw it out, and you know, production is a very difficult word to define. Production doesn't need to be 5 million, 50,000, 10,000, 100, or 4. Production could be a custom bespoke application that can help lives, right? It's a lower quantity, but it's a unique type of production. And what I'm getting at is, if you go on LinkedIn, you will see multiplying by the day more and more of these desktop systems like an Ultimaker, Lulzbot, you name it, entering the prosthesis world. Especially with a lot of these exotic now filaments that we can do, so they can come off of more of a desktop FFF machine to a patient. With all of that going on so rapid and all the unknown with desktop printed open chambers, all different exotic materials, no sourcing of materials like we do in an industrial method. It basically goes by what I think will look the best and what's the most affordable.
Um 17 Uhr findet auf der AM4U Area die Siegerehrung der Panelists Challenge statt. Wir laden Sie herzlich ein, in die Halle 11.1, Startnummer D29, dabei zu sein.
Back to you.
Dear AM fans, at 5 p.m., the prize-giving ceremony of the Panelists Challenge will take place at the AM4U area. We cordially invite you to join the ceremony and the stand number D29 in the hole number 11.1.
Yeah. Back to you.
Okay. So Penny, what I'm getting at is we see more and more of this being adopted on LinkedIn. It's, I don't want to call it sensationalized, but it's making people excited, and you're seeing a lot more little startup companies open up to solve these problems, and they're great applications because they're feel-good applications, and they really change the quality of life for people that can do. So my question is UL paying more attention to this open desktop market with all of these materials sourced around the world? Is that a concern for UL, and what are the steps that UL has taken to actually start to conquer this?
Yeah, UL has taken a pretty, I'll say, broadest approach where we're involved in multiple aspects of additive manufacturing. We definitely see benefits. We're starting to see more and more products be submitted to UL for safety certification. But the key there is that the materials submitted still have to comply with the same requirements. It doesn't really matter to UL how the product or part or piece was prepared, what process, what method, it still has to meet the safety performance. And that's just one area of UL. We're getting more into those residential and desktop printers where we just finally certified the first product to UL 2904, which is an ANSI standard on 3D printer emissions. When you think about the things that, these kids now or even adults have a small printer in their bedroom. The emissions, the DOCs that are coming off these, what's going to be the long-term effects? And UL's getting into that part. So it's not your traditional risk of fire, risk of electric shock, but the third one, which is injury to persons, that could be that long-term chemical risk that UL's involved across the whole broad spectrum.
It's very interesting that you say that because, when you think of the desktop FFF type system, you think of kids, you think of adult hobbyists, but I walk into professional bureaus like a Dinsmore, I'm seeing more and more of them in the professional world assisting in any way they can. And by the way, they're not in the lab. Half of the time they're not in a lab because of the word desktop. So how do we get that bit of information on the safety and especially emissions over to the professional market rather than the home market? And is there any movement in there? Is there any concern on your end, Jay, when you bring in a small piece of equipment like that?
Yeah, that's why we pretty much stayed away from desktop. We have one, I think, or maybe two. But those are for one-off prototype stuff. We're not making production parts on there. So
Making toys.
Yeah. But yeah, it's an interesting one. We build a lot of medical, anatomical models and different things, and it is it's scary a little bit, It's a big deal. It's a big can of worms to open. Just again, like I said, walk through here and there's material everywhere.
And you're printing.
Yeah.
Well, we're all here.
And I see that too. I go as a travel around our companies global. As I go around in the engineering offices, and there's a photopolymer system sitting on the desktop right next to the guy who's designing the parts.
Yeah.
And I know that whatever waste is coming off that machine is not going through a proper waste channel. It's going in that trash can right there. And so, it's going to be a conversation on the spot there, is that maybe this isn't the best place for it. But I'm going to tell you that it bothers me there, but I worry about these things as these are prosumers. So these are going to wind up in people's homes too. And I have, waste disposal come to my lab a couple times a week. And I know they're not driving up to John Doe's house.
That's a great point, Larry. You walk into a design room, everyone's going to have a mini system on their desk so they can pre-flight their designs and then push it into more of the industrial machine. Well, a lot of people are adopting resin printers. Resin printers are very impressive, high-fidelity machines. Well, everyone knows that when a resin printer finishes a print, it now needs to be cleaned. So how do you take green state material that's on a designer's desk and bring it to the process of washing it in isopropyl alcohol, drying it, your glove station? All of those things are messed, but I think a lot of this has been clouded because of the word desktop, so.
But if you look at it too from an educational perspective, I'm a huge proponent of STEM, and I love seeing all of the students in elementary school all the way up through college, obviously, learning to code, right? Learning to print their own parts. But back to what Ken was saying, how do I don't even know that we're, and as a grandma too, I don't even know that we're protecting our own kids in the schools while they're learning to print so they can become engineers in the future and be able to use all these great tools that we're out making and utilizing. So, big great idea for, can you talk about what you're doing from that perspective too?
Yeah, you all made the announcement. We released the ANSI National Standard last year, this year, I should say in January. And like I said, the first printer has gone through and just received its qualification. We're actually demonstrating here. And it's really nice to see. And many, as I'm walking through the entire Formnext, I'm getting asked questions. How can we actually, go through this process? How can we ensure that the products we're using are safe and environmentally? And Jason, you mentioned before, some of those waste disposal products, especially for the resin printers, are an environmental concern as well.
Absolutely.
And we're looking into that and seeing how we can help with safety site certification, with facilities, and with printer certification.
I mean, show me one designer that has a spill kit sitting nearby, and I'll just end this talk now. I mean, I don't think that's happening.
It's called a couple of meetings.
So we're getting close to running out of time, but I still have two smaller topics that I want to bring up, and one of them that fascinates me is, we have a lot of veterans in this industry that have pushed the technology, and where younger people come in and take it from there and bring it to the next level. We all know the younger generation buys products entirely differently than 5 people, except for you on this stage. So the younger generation thinks about things a little bit differently. There's very interesting articles out there regarding, big brands are spending less in advertising now because the consumers, the younger generation, are actually, these unboxing videos are actually advertising the experience and everything about the company they're buying from. These are important decisions. And my question is, and we don't need to go super deep in this, I just want to know if it's something that comes up, especially when you have this new wave of designers and makers coming out of the schools wanting to get into manufacturing and more creative building of things, is sustainability. How much are you hearing when you're educating a client or something like that on, this is how we can do your application, it's a great product, we can take this through, but is there any type of, let's rewind a minute, what is that material exactly made out of? How is it going to, how is it going to break down on the earth? How are we going to stop filling landfills just filled with plastics? Do you hear any of these types of questions?
That's really interesting, because more and more, that's what I hear because I am traveling around a company a lot lately and talking about additive, part of our knowledge, education of additive manufacturing, where it is today and where it's going. And we start talking about these products, and more often than not, I get this question: is it recyclable? Is what you're making recyclable? And there's, and part of the answer they can come back with is like, well, the stuff that we're doing is no. But there's kind of a give and take there, because we also don't have a lot of the waste that we have in injection molding. So screws and for cold runner tools that we'd be not reground for medical, but we'd be scrapped. So we may be recycled somewhere else, but there is kind of a give and take. That is a question I get more and more.
Yeah.
Can it be recycled, and will it be recycled?
Yeah, I hear it almost on a daily basis, and I hear it more from my children than I do from my peers in the space. And it's very interesting, and there's a lot to be said there. We have the younger generation is a very responsible generation these days. Like, the old jokes about when we were younger don't apply really anymore. It's a whole different beast, and more of these talks come in, and I think it's an important thing. I think it's a very important thing, and I think we're going to hear this more and more, so just something to throw out there. So the last question I wanted to bring up actually is a very important topic to me, and I think this one is really driven by the audience, and I think it's the audience's mission to really give these types of answers to the topic that we're going to talk about. And the question is we have all of these shows that are developed around this space and what we're doing. We have shows, we have conferences, we have user groups. These are very important pieces of the puzzle to what we're doing. This is where we find out about technologies. This is where we learn from our peers. This is where we throw in the wishes of what we want from the OEMs and the developers. My question is, are these shows supporting this crazy reality that we're on? And if they're not, how do we get that information and feedback to these shows so they can start? The technology evolves crazy. We also need the shows to evolve to support that. So I want to throw it out there. Everyone has a different, unique perspective on attending a show like this, Rapid, like AMUG, FabTech, you name it. Are the shows evolving to what we're doing?
I can start. I can give you a little. I was in one of the biggest plastic shows a few weeks ago up in Dusseldorf, and I was really surprised to see so much additive manufacturing. And it was really nice to see that the additive manufacturing is really getting into that material space. And likewise, walking through here, I'm starting to see some of those huge plastic manufacturers really now investing in additive manufacturing. So I'm seeing that crossover now, which is really nice, and I think that'll help develop the industry a lot better.
Yeah, I think this is my fourth Formnext at this point, and obviously the conference has grown substantially since I started attending. So I think it's a catch-22 relative to, is it actually enabling what we enable it to do, right? Because we have to provide that feedback, and we have to identify what we want those conferences or these conferences to truly accomplish so that they can structure accordingly, right? So I've seen growth, I've seen maturity in the conferences. I can't say that it's not meeting my expectations, but I think that there are opportunities to get maybe a little bit more specific within the conferences and have a little bit, maybe more focused areas so that we can all further specific conversations that we need to enable.
I agree. I think deeper dive and more educational focused, in my humble opinion, rather than just like selling stuff. Like it all goes back. I go there all the time. It all goes back to the educational piece and our duty. I think everybody here, again, the whole world, we have like a big glass over us right now that the world is looking at 3D printing and additive manufacturing, and I think that it's our duty to educate the world first before we want to make a buck. That's my opinion. There's conferences are certainly there's a number of them in there, and they have different focus. And I do like the focus on education and all of them, and I think that I go to different conferences for those different reasons where their strengths are, and I think that part of the education is educating on which conferences do really well at those. Yeah. And so there's some that I really support. I won't go into the naming all of the conferences I support, but some are really, really strong on those. And if that's what you really want, how do you know who those are? Yeah.
Would you like to answer that?
Yeah, of course. We talked this morning actually, and it inspired me a little bit. From our perspective, it could be a little less marketing actually. Here, I have the feeling that people present a lot of solutions that are not really working still and so on, and it could be a little less marketing and a little bit more real problem solving actually, and collaborating.
I agree. It should be more hands-on doing of example rather than the glossy, sensationalistic approach to it. Oh, the high level, what you can do with this technology. So what I'd like to do is, anyone have any questions that they want to throw into the mix here? I would love, we're running out of time, but I think it's important to get some in.
Thank you. We heard a lot about what OEMs are doing that's sort of inhibiting the ability to move more applications into serial production. And I don't think we have any OEMs on the panel, but I think Tom is here, and maybe there's some others in the crowd. So my question is there any appetite from the OEMs in consideration of some of the challenges that we heard related to material variation, printer variation, software variation? Is there any appetite for, instead of developing specifications where a material is locked down, a printer is locked down, having a specification built around a performance requirement or a material property characteristic, and then giving that flexibility to the supply chain to come up with that part, regardless of how they get there, how they print it, what they make it from, if it meets the performance demands, is that sufficient?
I would say that this is a conversation that I had just about 2 weeks ago within my company over specifications, and what we're talking about is this one of our parts has this part is to be produced on a carbon M2 in this material, and our internal talks were is that can we move away from that and go into performance characteristics and not even specify a machine or a material, but these are the performance specifications for the material, but not name the material, and what does this part have to do? And I think it's was kind of strategic to start thinking that way. I don't think it will be there anytime soon, but it is the way that we're looking at it.
Well, and I think what I heard too is take what you're saying and think back 50 years, right? Or think back today from where we started 50 years ago with forgings and castings. They don't lock down a specific forging machine for a forging press to come off of, right? They just say that it needs to be Tie 6.4 meeting these mechanical properties. There may be obviously some additional details, but functionally, it's that. We need to get as an industry and an OEM to that point where they're thinking like that. I don't know that the technology is ready for that yet, holistically, from raw material all the way through the printers, but I think we need to get there, but I think it's going to take us some time to do that as an industry.
I could also answer working for one of the top 50 automotive industry companies. We change every day. Anyhow, from our perspective, it's multifaceted. Today, we know what the materials are, whether it's a cast iron part, a die-cast aluminum part, an injected molded polycarbonate part. We know what that is all about. We designed way back when for those components. Trying to get the mind to shift on how to design a part for the technologies today versus just the material is a really tough thing to do, because everybody's so used to designing a part and they'll say, hey, build this in additive, and you look at it, it's like, why? It's the same part that's already on the vehicle. Do something unique, make it worthwhile to build an additive and make use of how that technology operates. The second facet of that is, from a material standpoint, it's whatever material is available. Today, the OEM wants you to design the part to meet that material and machine criteria. That doesn't work that well today, and there's a lot more, as Jay pointed out several times today. There's hundreds of different material componentry or companies out here right now, and from an automotive perspective, I haven't seen one yet that I'm aware of, and maybe you could answer from the UL perspective. None of them meet the Federal Motor Vehicle Safety Standards for cockpit componentry. So head impact criterion, smoke, flammability, self-extinguishing, toxicity. So until that gets resolved and they get tested, then we don't even look at it from the inside, of cockpit. And then the next step is on the certification. All production parts have to be what we call PPAP. So, and the slightest thing will throw off PPAP anymore. If you move the machine from here to here on your show floor or your shop floor, that whole system all needs to be PPAP once again. It's very costly, it's very time consuming, and it's $1 million a day an hour to shut down the production line. So you have to think very hard of what you're moving and what you're not moving and why. So it's very difficult.
You brought up 3 good points there, and point 1 is my life. It's the educating for designing for additive. I can't tell you how many parts come across my desk that when I just open up the drawing, I just laugh and chuckle, what's wrong? And it's just like, this part was designed 7 years ago. Why are we printing this? Just to say it was printed, or what they want to have it 3D printed? What I'm getting at is, we talk about production and the positives of digital production. One of the main points is, and this is an arguable point, is you don't have to spend that money up front for cutting a tool. You can get into production faster. But what no one's talking about is the money that you're spending in resources to go out and educate 25 to 35 designers over time put them through validating exercises to understand what's a good part, what's not a good part, how to make it a good part. That starts cutting into what I call a tool cost. That is education. We all know this. Outside of Germany, is very expensive, especially in the United States. So right there, that's your tool cost now being pushed into design for education. And I think we can all agree on that and don't even need to talk about that. And point two, I'll let Roxanne and the rest pick up on that if they want to and see where it goes.
No, I mean, I think you're exactly right. It goes back to data. It goes back to education. It goes back to training. It's understanding historically what drove us to all of the standards that were created, all of the manufacturing processes that were created. To your point about PPAPs and understanding why those are in place, a lot of the younger generation doesn't really have a clue about the quality requirements. They just think that they can print pretty parts, right? And at least I'm starting to see as I'm walking through Formnext, instead of just having pretty parts on everybody's display counters, yeah, that's still all pretty, but they're starting to see some real mechanical property data that a presenter can attribute to a pretty part that's sitting on their display stand. So I think we're starting to see some progression with that, but I think we've still got some industry-wide training that needs to happen and industry-wide focus on being able to enable those types of improvements holistically.
Well, it has to be. You're going to go into looking at printing parts in production and get away from traditional. It's like we ask so many questions. Phil, who's one of my account managers, and he walks into my office with something, and I'll be like, "Did you ask this? Did you ask this?" I'll throw so many questions at him that he's like, "Oh my gosh," because I want to make sure that we're serving that client well, no matter who the client is, and that the technology and material we pick is going to work. That'd be cool. And not just work for like today and tomorrow, but if it's production, we can sit here and start talking about like material testing, aging testing. You want to go nylon, MJF, HP, awesome. Okay, a water marine application, they've been making this part, and there's value add there because you've done DFAM and you've reduced tooling costs and all these awesome things, but is that thing going to survive for the next 30 years out on the ocean? I don't know. So that's a whole different, it's...
When you have to have the material scientists on board to enable that and be able to confirm that, as you're developing your parts, your materials, your processes, all of that still combines. And I don't know about the rest of you guys, but I think we're short on material sciences as an industry, and we need to be working with, I'm actually on the Texas A&M's Material Sciences Advisory Board to help create undergraduate programs to teach them about material sciences, to teach them about environmental concerns, the undergraduate students, and be able to enable that. So I think you're exactly right.
Yeah, and you have to also, I think, designing for additive is an interesting thing. My daughter, Cora, is 7. My son, Phoenix, is 11. I put a couple of printers in their school, which is awesome. And a lot of younger generation coming up are learning how to design for additive, but there's one thing missing. They're not paying attention to traditional manufacturing. Or are we paying attention to that too? Because we can't just go, yeah, everything's additive, because that's a big issue.
One point on that. The material side of things, I got involved with developing a new material, and then we had to do the tensile bar testing. When you actually look at the standard tensile bar testing, you build the part, you leave it for 7 days, then you test it, and that is what you get off the data sheet. So basically, a lot of the materials that come off these machines, they're in your hands within 3 days. They're not even at the point where they should be, or what you're expecting. So that's a real problem.
Exactly.
Another point that came up was I did a talk with the children. They're all on about being green, and what you see is you've got all these fancy bits around. And it was an inventor said to the children, if you're going to print something, make sure you use it. Otherwise, you're actually printing the next landfill.
Absolutely right. Absolutely right. Tom, to answer your question on certification, especially looking at the E&E, electrical and electronics, there are about 50,000 certified materials out there. Well, there's less than 50 certified materials for additive. So you're talking a huge difference.
And our kids are playing with that.
Exactly.
And we're printing food with it. All kinds of crazy things.
Can I ask a question about that? Because it's funny, my neighbor worked in aerospace for many, many years, putting satellites and things in space. He just retired. I've lived next door to him for 6 years, and I still argue with him occasionally, where he says, no, you can't send these parts in space. That's not going to work. You can't 3D print in titanium and 316, all these different materials. I'm like, Paul, yes, you can. Just Google it and look it up. And he still fights me because he's still within that traditional mindset of that, no, you can't do this stuff. We have to still machine and cast and do all this other stuff. So as part of that, the regulatory, and we only have 50 out of 50,000, that's kind of crazy. That doesn't make any sense to me. It's like, is that old mentality of holding us back? Maybe?
And it's also the unknown, because, again, we'll go into casting, right? We've been sandcasting for 10,000 years. I mean, if you go back and look at the history of when casting first started, it goes back.
The first casting plants, sorry to interrupt, I just want to say something really funny. One of the first casting plants that I saw like 25 years ago, I didn't fly for like a year. I was so scared. I don't know if any of you have ever been in a foundry.
So with that in mind, in today's materials, everybody wants to compare a cast aluminum to a additive component, and you can't do that. I know the chemistry between the ALS I-10 as well to the sandcast of A357 is probably, it's close. It's not identical, but it's close. But they react totally different when I'm sandcasting it versus when I'm permanent mold casting it versus when I'm building it in additive. So until you get the testing done where people feel very comfortable and confident, and today I wouldn't be confident making a dynamic component that's going to be under load, such as a steering knuckle, a control arm, or something like that, a chassis part out of additive, until I'm totally sure that it's not going to fail when I hit a pothole and it's 40 degrees below zero, and I hit something else and it shears or whatever the case may be. So that's part of it. The other part of it, and I'll bring up, when I first started doing the additive back in 1989, 1990, I had to do a presentation, and I started with my presentation of the old style when I started on the board, drawings on Mylar, and the drawings using steel plate print off of it. And then I did the CAD model, and then went on from there. The funny part was, from a 1952 D-truck, which is the Dodge truck, all the way through, at that time, current year, 1990 BR, which was a Dodge Ram. The part I used, which was a rear axle and rear axle housing, all the notes and nomenclature never changed. It was just carry over from year to year to year, because nobody, as time went on, understood what those notes were. Well, it was on the last drawing, so I'm just putting it here. It's like, but the machining operations and the material has changed over the last 50 years. Why is it still here? And it's just like the whole process of designing for additive. Well, I've always designed it this way, as a big solid mass. You don't need to do it as a solid mass if we're using additive.
I think that's very interesting, and I've seen a lot of examples of that where the notes exist for no apparent reason anymore. And I think after today's discussion, I think one thing is apparent, that the conversation needs to keep going. The more and more we have this conversation with people that are doing it, people that want to do it, that have those questions, I think it helps drive the innovation and the technologies to get it to where we need it to get it. But that's everyone coming together. No questions too stupid. No questions too dumb. I mean, there's a lot. I have tons of questions every day that I reach out to my network. I just want to make sure I'm getting this right. It sounds right logically, but I can't find any information on this. I think it should be out there, but we need to find these answers, and driving these shows and giving surveys and responding back to the user groups, like what you like about these shows, what we need from these shows is more important than anything. So I just want to thank everyone for their time today and our panelists, but more importantly, I want to first thank AMUG for setting this up on this stage, and a big, huge thank you to Link3D, who's trying to tie all these processes together in a whole downstream workflow and stuff like that. And there's this synergy with everything coming together. So thank you to everyone involved. Thank you to our panelists, and thank you guys for coming out today.